Alright guys, we're polishing off chapter 4 today about loops and about the switch statement. Kind of an odd pairing there since one is a form of selection and the other is of course a form of looping. Two disparate concepts, but that's fine. We've seen an example of the switch and we certainly have seen examples of loops. So if we have our notes from the last lecture, right, we did a switch here. And based on the value of it, if you made a 10 or a 9, you printed out A. If you made an 8, it printed out a B. If it was a 7, it printed out a C, and so on. So we're going to do a few more loop examples, just for funsies. So, and one leading up to the homework. So one of the things we're going to do is to make a string that and a loop that iterates through the string to find a piece of data that we're looking for, or to count how many periods are in it or something like that. And there are methods, you know, for the string class that'll do things like that, but we're going to do it ourselves. It's always good to know how it works in the background. So starting off, of course, making my lecture. I always like to remove the package from the main class. You don't have to, but I like it. All right, here we go. So what's the first thing we're going to do? We already know how to count, you know, from 1 to 10 or whatever. That's pretty trivial. Instead, let's do something a little bit more useful. Let's make a string, right? Call it password is equal to you know, and we're just going to put some silly password in here, like, you know, white.castle. I'm hungry. I'm going to get some White Castle. I don't think there are White Castles around here. Anyways, there we go. So that's our password. And we're going to count the number of periods in it. There's more than one way to do this, but why don't we do it this way? So we're going to iterate through the string. So we need a counter. Just going to call it I for the iterator. I'm going to set it equal to 0, and I'm going to go through the length of the string. So while I is still less than password dot length, come on, don't make me say please wait. Okay, fine, I know what it is. Semicolon I++. All right, let's get the character and inspect it. So the character CH is equal to password, can I spell password correctly? Password dot get, excuse me, dot char at position I, right? Now we have a character. We could print it out, we could do something with it. Well, let's just see if it's equal to a period, right? So if CH equals, and since it's a character, not a string, we have to use apostrophes, not double quotes. Then that is the position that counts, right? We have found our period. So why don't we put in a counter in here that says how many periods we found or the position of the period? Which do we care about? Why don't we put where we found it, right? So let's call it first period. That's going to be our flag, right? That we're storing the index. So first period, we don't have a first period yet, so I'm going to set it equal to -1. Once we find one, I'm going to set first period equal to that value. But what if we've already found a period? In that case, we're going to want to set our second period. So int second underscore period, or we could just call it last period, right? Last period equals -1, right? And so here, if the character is equal to a dot, then if first period is still less than 0, that's the position of our period. So first period is now equal to the index counter. Else, the second period is equal to our index counter, right? Because we've already set the position of the first one. And I should call it last because we're going to iterate all the way. Oh, I did call it last up here. So last period is equal to our current position, right? So we're going to find out where the first period and where the last period is. So why don't we say white.castle is.fun. That's going to be our new password, right? Just so that we have a first period and a last period. And we have a for loop that's inspecting it, looking for the dots. Now I don't know why we care about where the dots are in a password, but that happens to be our string, so let's just go with it. And so by the time we get down here, we should have a first period and a last period. And we could extract that string, right? We could extract that substring if we so chose. So to do that, we could use the Java substring method. But we're going to be more awesome than that. What are we going to do? We're going to build our string starting with. Now let's go ahead and use substring. So what does it do? Starting at position 7 in this example and going up to position 17 in this example, we're going to pull out the substring. So what are we going to do? We're going to check to see if we found any periods at all. If we didn't find any periods, then we can't extract it, right? So that's the end of our for loop. Now let's check. Did we get a period? If first period is equal to -1, right, or less than 0, so first period equal -1, we didn't find it, right? So let's just set our string to empty. This is the result of the stuff between the dots. So string result is equal to that, right? We don't need to do anything if there's no result, right? Or we could print some kind of error message, right? Let's not do that. Let's say if the first period is not equal to -1, we care about getting the substring. What if we never encountered a last period? Well, then we want to get everything to the end of the string, so we would set the last period equal to the length of the string, right? Password dot length, parentheses and parentheses. Now if we were really going to do this easily rather than illustrating a loop, we would use password dot or string dot index of, right? Index of will find the character, and then we would use last index or index last. I know I saw that. Right, last index of to find a period, the occurrence of the last period, rather than spot this. But this is a common kind of operation to do, to go through a set of data, inspecting the data and accomplishing tasks based on the results. So we're going to do that. So we have our first period and we have the position of the last period, which is either at the end of the string if it was never found. We're going to pretend that it's at the end of the string, or where it really was found. Now we can extract it, right? So result is equal to password dot, and this is not going to be quite right, substring starting at the first period and going up to the last period. And then let's print it out. So system.out.println or printf parentheses quote data between dots equals, why not put some braces there? That's a brace. %s because we're printing out a string. End %s \n end quote. And what are we printing out? We're printing out our result. In parentheses semicolon. I think that's going to work. Let's watch it go. Now what's this warning here for? The assigned value is never used. Says who? We're using it right here. Okay, so it's a lie. It's lying. I'm going to ignore that. So here it's running. Well, it's compiling first, of course. It's taking a little while to compile it. And it found it. The data between the dots is castle is fun, right? But really, the first, we did not want to include that dot there. what are we going to do? We're just going to modify our substring to start one passive position of the period, right? Because we don't want to see the period in there. It looks like it didn't go to the end, right? Excuse me, it looks like it did go to the end rather than stopping at that period. So I must have botched the calculation of the last period. Let's go here. Yeah, I overwrote the value of last period no matter what, and this should be an if statement, right? If last period is equal to -1, then last period is equal to password.length. So let's make that change. If last underscore period is equal to -1, or maybe less than 0 if you felt like going like that, then the last period is there, because we don't want to reset the value of last period to the end of the string unless one was never found. And as mentioned, we want to skip that first period, so we're going to start there. Now we're going to go. I'm going to grab output and pull it up here so that we can toggle between it. And there's our output, right? We found it. We found the values between the periods by using a for loop, recording the period, the index of the first period, recording the index of the last period, and then extracting it with substring. Hope that makes sense. What else could we do? We could check to see how many uppercase letters were in our password and how many lowercase letters were in our password, and whether it had a digit or not. And that's the kind of thing that you probably did in fundamentals of programming if you took fundamentals of programming. Let's just do a little bitty bit of that. So to get that to work, you would use character, which is a wrapper class for the char data type, which has got a bunch of methods attached to it, is uppercase to see if something is uppercase. And of course, you could use is lowercase in order to determine how you would get the lowercase. So let's go look at possible methods of the character class. You know how I like to do it. I just like to type character dot and see what it pops up as a list. How about is? Where are my is functions? Is a digit? Is uppercase? Is lowercase? Is mirrored? That's interesting. Is a space character? Is white space? Guess it could be a tab, right, or a character term. Notice that there is no is punctuation, but you could decide that it was punctuation based on the idea of whether it was an alphabetic or digit character or not, because if it was not alphabetic and not is digit, then you know that it's punctuation. Or we could say is not alphabetic and is not digit and is not space, right? Those would be the cases where it was punctuation. So let's do that again. Let's have another for loop that iterates through it. Let's make sure that we're lined up in the correct space, though. I have a feeling, what am I looking at? I'm looking at an old lecture. That's why I'm getting confused. All right. So what are we doing now? We're going to count, the number of punctuation marks and the number of spaces in our password. So how do you spell punctuation? Punctuation, characters, and the number of spaces in the password. So same business. Let's use another for loop. We could just even go back and copy it, but instead for, parentheses, int I is equal to 0. Keep going through the length of the string, so I is less than password dot length, parentheses in, parentheses, semicolon, I plus plus. Now suddenly I'm interested in the idea of a for each loop. So I'm going to type something and see if it's syntactically correct. And if it's not, I'm going to delete it. So for char ch colon password in parentheses. And that doesn't work. It works in some languages. Works in Python, doesn't work in this language. So we're not going to do that. What this would have done if it had worked would copy each letter of the password in turn into that variable, which would be a shortcut for what we're just about to do, which is to extract that character at that specific position using .char@. So char space ch space equals space password dot char@ with a capital A. Char@, why did you erase what I typed? Parentheses, I in parentheses, semicolon. And let's check to see what that character is. That'd be kind of neat if we could use a switch case, but we really can't. I don't see how we could do that here. So we're just going to do some stuff. If the character is a space, so if, parentheses, character with a capital C, character dot is space char, parentheses ch, that means that it is a space. So we need to out increment the number of spaces. Number of spaces plus plus. Now, of course, I have not created that yet. So why don't we come up here and add a num spaces counter and initialize it to 0. Num spaces is equal to 0. Now let's check to see if it's punctuation. Our rules for punctuation is that it is not a space, and it is not an alphabetic character, and it is not a digit. That makes it punctuation. You know, we probably ought to, make a method that would do that, because that's 3 checks, but let's just go for it. So I'm going to come back and add the nots. I'm going to come back and add the exclamation marks in a minute. So if character dot is space char, parentheses ch in parentheses, or character dot is alphabetic, parentheses ch in parentheses. I'm going to continue this on the next line, and as a matter of fact, I'm going to continue them all on the next line. We haven't closed our parentheses yet. So, or character dot is digit, parentheses ch in parentheses. All right, now that would tell us that it is a space character or an alphabet or a digit character. But really, I want to see if all of that is equal to false. So what I'm going to do is I'm going to say if not, right? And it still has to be enclosed within a parentheses. I hope that makes sense. I could probably reword it another way, where I said if not character is space and not character is alphabet, and this is using something called De Morgan's law, where you can expand a not with followed by parentheses in this fashion by putting not on each operand and then switching the and or vice versa. And not character is digit. Now it's time to close our closing parentheses. Then what is it? It's a punctuation. Num underscore punct plus plus. And of course that's another variable we need. And num punct equals 0, semicolon. Let's go ahead and print those values out already, just to make sure that we like what we're seeing. System.out.println parentheses spaces found equals end quote plus num underscore spaces, right? And then system.out.println parentheses quote punctuation characters found, punctuation characters found equals end quote plus num underscore punct. That should be enough to test it. We have 2 dots and we have no spaces in our password. I remember adding the 2 dots. Oh, there's a space. So when it's done, it should say that we found 2 punctuation, 1 space. And that's true. That is exactly what it found. We could check, whoopsie, come back. We could check for is digit and is uppercase and is lowercase, finding the number of uppercase letters, finding the number of lowercase letters, and finding the number, right, of digits. What would we use? Although we haven't demonstrated it, we could use character dot is upper, character dot is lower, and character dot is digit to check for, respectively, uppercase, lowercase, and digits. All right, we're already most of the way there towards doing password validation. So what are the rules for passwords that we're going to follow? Right? A password must be 8 characters in length. We're just going to arbitrarily make a rule that a password can't have a space. Now, personally, I think passwords should be able to have spaces, but just for the purpose of writing this program, a password must have no spaces. A password must have at least 1 uppercase. A password must have at least 1 lowercase. And lastly, a password must have, where'd that come from? Must have at least 1 punctuation. So if you're going to write a program about this, and you are, then write a program that asks the user for a password. It uses a for loop to count the number of uppercase, lowercase, digit, space, and punctuation characters. Then, using the rules above, tell the user whether it is a good password or not. So how would you check the length? You just check, password dot length, parentheses in parentheses. Okay. Tell the user what was wrong, right? You got to at least tell them one thing that was wrong. Even if all the things are wrong, if you just want to write it so that it tells them the first thing that it finds wrong, like, it wasn't a character, password must be 8 or more in length, that's fine. Or if you want to tell them everything that's wrong, that's also cool. So tell the user what was wrong if there is a problem. Okay? So that's our homework based on that concept. All right, so let's do one more example of something with a for loop. And in this particular case, we're going to utilize something known as the ideal gas law. And who cares about the math, right? You're not taking chemistry or physics, so you don't need to know this, but we're going to use it anyway. So gas law is PV is equal to nRT, where that's the pressure of the gas, that's the volume of the gas, that's the amount of the gas, and that's the temperature. In other words, pressure and volume are inversely proportional. If you increase the pressure, the volume of your balloon would get, smaller, assuming outside pressure, right? If you increase the outside pressure, the volume gets smaller. If you increase the volume, the pressure decreases, right? Because the pressure inside the balloon is, there's less pressure in it the larger the container is. T is the temperature. You probably know that if you decrease the temperature, the volume of a gas also decreases. So if you stick a balloon in the fridge, in the freezer, as it gets colder, the balloon would shrink. So we're going to use that law. What are we going to do? We're just going to calculate the volume as the pressure increases. because it's going to get smaller and smaller and smaller. Let's do that. So we have a constant r here. We're just going to set that equal to its accurate value. Double r is equal to 0.0821. And it's not its precise value, but it's good enough. We're going to just arbitrarily say that we're at room temperature. We're going to say that we're at 70 degrees. Now to cheat, I'm going to go and find out what 70 degrees is in Kelvin, because this formula requires Kelvin to work. So 70 F in Kelvin is 294. Why don't we just say 294 rather than count all those fractions, right? So double T equals 294, and we're going to add a comment. 70 for room temperature in Kelvin, right? Kelvin's just another temperature scale, if you're not familiar with the idea of Kelvin. It's a temperature scale that has no negative numbers. There's nothing below 0, unlike Fahrenheit and Celsius. There is an absolute 0, which is the temperature at which there would be no energy in the matter at all, because temperature and energy are related. All right, that'll take, and so let's say that we are dealing with 1 mole of gas. Who cares what a mole is, right? So double N equals 1 mole of gas. If you're not a chemistry or physics student, you don't care what a mole is. And we're going to print a table showing pressure and volume. We're going to iterate through the pressure, which is measured in atmospheres, and we're going to calculate the volume. So in order to calculate the volume, we're going to need to rearrange our equation. And just doing a little bit of algebra, instead of multiplying, we're going to divide by P. Good enough. Let's write our for loop. We need a variable to indicate V. So double V, no, we're going to need V is going to be volume in liters. And we need a pressure, so double P, which is the pressure in atmospheres. What is an atmosphere? Well, you know, it's if you're at sea level, it's the current pressure. But if you went up on, you know, the Himalayas or whatever, there's less air around, and so the pressure is lower. It's less than 1 atmosphere. So pressure in atmospheres. You didn't think you'd be doing this much chemistry or physics today? All right. Anyways, let's go. So for, and I'm not going to redeclare this variable P. I'm just going to use it. And I could make them all lowercase letters, right? It's kind of nagging me that they're uppercase. I'll probably mess it up in my writing downstairs here if I leave them, some of them uppercase. So for P equals, let's start from half an atmosphere and go up to 2 atmospheres. Or let's start, I don't know, yeah, half an atmosphere and go to 2. So P is equal to 0.5 semicolon. Keep running while P is less than 2 semicolon, each time adding 0.1 to it, right? So P plus equals 0.1. That's our loop. Range from 0.5 to 2.0. That's what we're doing. That's our range. Now we need to calculate the volume based on that equation. So V is equal to N times R times T divided by P. I just kind of, you know, added the asterisks between the N and the R and the T. And let's print it out. But I want to print it out in kind of a pretty format. Like if we had a homework assignment, which we do based on this concept, you know, I want to see the numbers come up like that. But right off the bat, I don't know what the decimal places are going to look like, and so I'm not going to make it pretty from the get-go, but then we're going to modify it so that it is. So let's use a printf, because a printf lends itself towards looking pretty later. System.out.printf, parentheses. Let's use a formatting string that just prints %f space %f, one for pressure and one for volume, right? So P and V. This is just our first run through to see that our equation is working. I just happen to know that at one pressure, having done these formulas often enough, the volume is going to be 22.4. I just happen to know that. Let's go. Watch it run. If I don't have any syntax errors. Green arrow. I forgot to put a \n on it, but anyways, at 0.5, our volume is 48. Yeah, I gotta go back and add that \n. I can't make heads or tails out of what I'm seeing. And let's put ATM here, right, to indicate that it's in atmospheres. And let's put L here to indicate liters. We could put those units up above everything. But just for now, let's run with that. There we go, right? So at 1 atmosphere, it's about, did I say 22.4? It's coming out 24. Allow me to pause the recording because it's not getting the answer that I want. All right, it didn't take me long to figure out what was wrong. My problem here is that when I said it was going to equal 22.4, that was at 0 degrees Celsius, right? The freezing point of water, not at the temperature that we chose. You know, so at 30 degrees Fahrenheit, it would have been 22F, but instead we used 70 degrees Fahrenheit. You know, we did an approximation of that in Kelvin. If we change that temperature to 272.15, which is a freezing point of water, that's 32 degrees Fahrenheit, and if we run it, we'll see the answer that I was expecting. 1 atmosphere is 22.3. Well, that's pretty close. Probably because I used an inaccurate value for R, right? I didn't get R equal close enough. No, but if I use the accurate one, I think it would be even more off. 08206. I think that's the value for R. Let's Google that up. Yeah, 0.08206. All right. Anyways, that's going to be more precise. Let's let it run. All right, that's looking pretty good. Now, if we're going by, you know, 0.5, 0.6, 0.7, we have a whole bunch of extraneous zeros here. So let's just give ourselves 1 decimal place, right? So we're going to use 0.1F. And then does this really need to be as much as it is? No, it doesn't need to be. So why don't we round this one off to 2 decimal places? So in my code, in my printf statement, I'm going to make it %.1f, display 1 decimal place, and I'm going to make this one say %.2f. I'm going to run it. All right, that's looking good. What if we let the atmospheres go, you know, all the way up to 20 atmospheres? Just for funsies, right? So our volume's going to get smaller and smaller as the atmospheres turn into a crushing amount. Let's do that. So instead of stopping at 2, I'm going to keep going while P is less than or equal to. I don't know why I didn't make it equal to last time. Here we go. Keep going. Right. Now, if we look at it, it's no longer evenly lined up, right? And so we can specify the total width of the numbers that we want. 1, 2, 3, 4, so that it will pad these out to be 4 characters wide. So we're going to make it %4.1f. See if it looks prettier. %4.1f. And what about these numbers over here on this side? Looks like they're all the same within the reasonable changes. Well, it did start to decrease here at 1/2 an atmosphere. So if we went to like 0.1 atmospheres, it would probably be pretty large. Let's do that. Let's change it to 0.1 atmospheres. There's no such thing as 0.0 atmospheres. That pressure would be 0. We would be dividing by 0. We would get an error there. But we could start off at, 0.1, going up to 20 atmospheres. Maybe we don't need to increase by 0.1 each time. Maybe 0.5 would be enough. But anyways, let's let it run. We can always just scroll up and down. And so at a very low pressure, it's very large, 22 liters, right? You know what a 2-liter bottle of Coke is. It's like as much size as 10 2-liter bottles of Coke would be. And then if you increase the pressure to 20 times what it is on planet Earth, then it would occupy just a small fraction of that, right? 1/10 of a 2-liter bottle. Why didn't it go up to 20? I thought I made it less than or equal to 20. It's probably due to floating point rounding error. I'm not going to fix it. So here we go. Let's pad this one out to 5 characters because the largest piece of data we're going to print out is 5 characters. So we're going to make that %5.2f. Going back to my print statement, %5.2f. One more test. Run it. Okay, that's looking pretty good. We might want to put some headers up here explaining what they are looking at. I think we could do that. Might take a couple of changes to get it to work right. So above our for loop, we're going to put a print statement that prints our header out. System.out.println. And the first one was pressure and the second one was volume, right? Let's see how closely those line up to where they need to be to make nice pretty columns. Looks like pressure's going to need, volume's going to need to be bumped over some, right? We could bump it over like 2 spaces and that'd be enough. Yeah, I think so. Doesn't have to be perfect, right? And then how about we put some underscores just to make it really look like a table. System.out.println parentheses quote dash 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 space 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 dash 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 dash. And we could keep messing with it until we got what we liked, something that we thought was pretty enough. For example, we might want to extend the dashes 1 more, right? And maybe we'd want to put the word volume backspaced or forward spaced 1 to make it look pretty. I don't know. I think that's good enough. I think we're done with our table. We might explain what they are seeing. So let's tell them what we are seeing. System.out.println amount of gas equals end quote plus n plus quote moles end quote in parentheses semicolon. Let's do the same thing for the temperature. We could just copy and paste that, right? It's just another print statement. So temperature of gas equals T Kelvin. And that's enough. They don't need to know what the value of R is because it's in universal gas constant. Gas law constant. They'll label it such up here. Adding comments to your code is always a good thing. All right. Let's see how beautiful it is. So here we go. Wait, that's totally wrong, right? I mean, we need a space there, right? We need a space there. It would have been nice to have a blank line here, but we're getting there. I think just one more series of changes and we'll get it to look good. So let's add a space in front of the word moles, a space in front of the word Kelvin, and why don't we just add an empty print line statement? Or we could use a \n in front of the amount, right? But I think an empty print statement will do the trick. All right, so there we go. blank line underneath it, but I'm not going to keep endlessly making changes to it. The amount of gases in 1 mole, the temperature of gas is that, and then the pressure versus volume table follows underneath. All right. Might have been interesting. No, we're not going to make any further changes. I think we are good to go. I think we have lectured enough on this. We know what a do loop is. We know what a for loop is. When do you use a for loop? If you know prior to the start of the loop how many times you want to repeat. In other words, if you're going over a predefined series of values, you know you want to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or from 0 to 20 by 0.5s. That's when you use a for loop. When do you use a do loop? If you always need to do the repeated thing at least one time. So these guidelines are important enough for me to add them on as comments, like at the bottom of the code. When to use a for loop? To iterate, to step through. I hate that gray color. Oh well. To iterate through a definite sequence of values. You're going to count through when the beginning and the end points are known. Or you have a series of pieces of data inside an array or something like that. You have a definite sequence of values. When to use a do loop? When the body has to be executed at least once. Executed sounds so violent. Performed at least once. Right, and we saw that in our last lecture. Right. We had a while loop, that's a pretest loop. So if the if the test score was -1 to begin with, it wouldn't even go in here. Or here in our do loop, when we set x equal to 100, but we wanted to run while x was less than or equal to 10, it'd go ahead and print that because a do loop is a post-test loop. Whereas the while loop, it would not go in here if the temperature was 100 because it does the check at the beginning. It's a pretest loop. Yeah, I guess I had the word post-test down there and pretest anyways. That's the last note. All right, so when do you use a do loop? When the body has to be executed at least once because it's post-test. And while loops and for loops are pretest. So when do you use a while loop? If the other occasions aren't true. So in all other cases. Now honestly, you can use a while loop to do a for loop, and you can use a while loop to do a do loop if you're clever enough. That's why the Python language doesn't even have the do loop. So kind of like the while loop is the one loop to rule them all and into darkness bind them if you're a Lord of the Rings fan. But the for loop sure is handy, right? So you want to use a for loop if at all possible, but if it's one of these circumstances where the body has to be executed at least once, no matter the starting values, you do it as a do loop. And if neither one of those other two cases, the preferred cases, then that's when you use a while loop. Okay, so what's our homework? Our homework is to implement the password program as written here. That's part 1 of the program. Now I'm going to split this up into 2 homework assignments, just so that you get full credit for each of them. This one ought to be pretty easy. You're just going to use some if statements after you modify your for loop, right, to have the extra things that it needs, like is upper to increment a counter for uppercase, is lower to increment a counter for lowercase, and is digit, to check for numbers. Just going to have to add 3 more counters and then implement the rules down here with some if statements. The next homework. You're going to do a table that looks like this. Oh no, more chemistry, more physics. Well, anyways, what is this? You may have heard like pH balance, the pH balance of this, the pH balance of that. And you may know that anything with a pH balance of below 6 is considered, an acid, and below 7 is an acid, and above 7 is considered a base. Well, what does that really mean? pH. What is that representing? It's representing the number of hydrogen ions that are in the water. The more hydrogen ions there are in the water, the more acidic it is. So if you buy your low pH shampoo or whatever, it means that it has fewer hydrogen ions in it. Or if you're one of those people who thinks that drinking a water that is slightly base, it's going to have fewer hydrogen ions in it, right? Or if you've got some, battery acid and you're worried about spilling it on yourself, the reason it can do you damage is because it's got more hydrogen ions. So if you look at this, you can kind of get where it's going. It's another table, just like our pressure and volume table. But we've got a third counter over here, right, which is just the pH. So what are you going to do? You're going to create an acid-base comparison table. I give you the formula here. The number of H ions is this formula, 10 to the power of 0 minus pH. The number of OH ions is 10 to the power of pH minus 14. So you're going to create an application. I don't know if that's the correct homework number or not. The functionality is to generate that table. Hint, you'll definitely need formatted output. I found 16.4 to be a good format for the floating point values. And to do the math, you certainly are going to need to use math.pow to take something to the power of something else, right? X to the power of y, math.pow, x comma y. All right, I hope that makes sense. Even if you don't know a single thing about the chemistry, you ought to be able to implement that formula, right? Because it's just math.pow 10 comma 0 minus pH. And this one is going to be math.pow 10 comma pH minus 14. And then 2 columns. One for pH, three columns. One for the pH. You're just going to use a for loop that's going to count pH from 0 up to 14. pH could be an integer. You're going to calculate the H ions according to that first equation. You're going to calculate the OH ions according to that second equation. Go ahead and print out all this stuff so that it'll be a pretty print, nice table, right? Use formatted output to line things up in columns, and you'll be good to go.